Now let's do the finishing pass. So the one that says flat 2 was our roughing pass on the first operation, and the second one was our finishing. So now we're going to right click on the routine. We're going to pick copy. Then we're going to select op2, right click, paste. So this fourth flat operation, we're going to right click on it, say edit. Everything on the first tab stays the same. Geometry, we need to deselect what's already in there, and we need to select the chain that's on the correct side of the part. All the rest of this stays the same. Go to the heights tab. Everything on here but this face, which was on the other side we selected, needs to be deselected, and we're going to select a face on the side that's facing us, just like we did on the last routine. We're going to go to passes. We're going to leave all this at default. And on the linking tab, we're going to leave all this at default and hit OK. We've now regenerated the toolpath for that feature. Now we're down to 2 more. This goes much faster if you plan it out and you've got features that are very similar. So now we have our 2 contours for the outside fillet. First one with the 1/2 inch ball. So we're going to right click on contour with the T6. I'm going to copy that. I'm going to pick op2 and we're going to paste. I'm going to right click on the copy and we're going to edit that. Leave everything on the first tab at default. We're going to go to geometry. Again, we're using a different chain. So we're going to deselect the chain. And we need to go to the chain icon and we need to pick open chain. And we start selecting the boundary that's on the side of the part we're cutting on. And again, for our last selection, you just switch over to chain so that it closes up the loop. Select OK on that dialog box. Our end selection to avoid this one here can remain the same. It's just the same surface, same offsets. Alright, we're going to go to the heights tab. Everything stays the same except for this last one. You see how our dark blue plane is way down here? Well, the whole reason for this plane is we don't want to hit the vice jaw, and look where it is. It's going to hit the vice jaw. So we want to move that. We're going to deselect the edge and we're going to pick the bottom of the fillet transition. That way that ball cutter doesn't cut any deeper than that plane. This is very important. We don't want to cut into these steel jaws. Go to passes, leave that at default. Linking tab, leave it all at default. Although we could pick a preferred lead-in point, which is not where we want it. Down there is not where we want it. So we're going to deselect that point. And we're going to select that we want to lead in on the top edge right there. And we'll hit OK. Alright, so we should get a few passes that are going to knock off the square corners so that the next cutter doesn't have as much to remove. And then we're going to go and we're going to go to the very last routine from the other side. We're going to right click on it, select copy, select operation 2. We're going to select paste. We're going to right click on the copy. First tab, everything stays the same. We're going to go to geometry. We need to deselect the chain that's there. Select chain. Open chain. We're going to start selecting around the perimeter. Of our fillet. Toggle back to closing the loop. Pick our last segment. Hit OK on that dialog box. Our collision avoidance can stay the same. Go to the heights tab. Everything can stay the same again, except we have to reselect this edge. Man, we want our edge to be this edge, not way down here. So we're going to deselect the edge and pick the corresponding fillet edge for the same opposite side of the part. This cutter will cut beyond tangency. And we go to passes. Everything here should be at default. And our linking tab, everything can stay at default. We hit OK. And we now have successfully machined the surfaces on the other side. Now, the machining graphic is going to show this material here, which is really gone. It's been more or less machined away by the previous cutters. You might get a little chunk fall off when the ball cutter goes around there, but there really isn't any material to stay there because the other side has already been cut to profile. All right, that's it. That's the programming part of the 7311 project. Again, you're going to fill out the tool numbers you used on your Traveler, get all that signed off before you're going to run it in the shop. Your instructor needs to look at your setup sheets. So what we're going to do next is we're going to do setup sheets. All right, so I've programmed these sides. Now we're going to collapse these down, and we're going to highlight the first operation. And we're going to change back to the view of the vise we had for the first operation. We want to position the model in an orientation that looks like how we load it. And we want to make sure this origin is showing. Zoom pretty far in, because what happens when you make the setup sheet, this image is going to be your setup sheet image, but it's going to zoom out a little bit when it does it. Now we go to setup sheet. You're going to have to pick a location where you're going to save it. Okay, so in my case, I'm just going to say desktop. And your setup sheet should look like this. Okay, the program number should match what you put in the setup. Scan all this so you make sure it looks the same. Your maximum spindle speed should be 8,000 RPM. Your minimum Z in this case should never drop below 0. Okay, and then we have our list of tools. But again, you want to have a graphic that you can see the origin in here. Okay, so that's the setup sheet for the first operation. You're going to print this as PDF and upload it in Canvas. You're also going to need a PDF to print in the shop. So you want to put that on a USB memory thing so that you can print it in the shop. And this becomes part of your deliverable for the end project. Okay, once you've printed that to PDF, then we can post-process. And we're going to use Haas Next Generation Control. You need to select where you're going to download it to, and the program number should match. Something to check is you want to check your configuration and make sure everything says no in this box here on the right. No, 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 no. For this class, when you get into 5-axis, you will be using that box. Okay, we're going to post. Okay, and you should get some code. If you view the NC code, this is what it looks like. This is what your code looks like. If you want to, you can manually edit this. It puts standard notes in here for all the tools. I'm going to put a note in here as operation 1. It's critical to use this right size parallels for all these. So I'm going to hit enter, and I'm going to type a new comment. It's going to be, say, use, make sure it's all in caps, and it has to have parentheses around it, use 1.625 parallels. Okay, so that is the height of the parallels. Let's actually put 1.625 inch tall parallels. And that way when the operator has this, they have a note there that tells them to do that. Okay, you should be able to go to File and Save. Your text file might come up in a different program. This is the one that Fusion recommended. You can use Notepad. Any text editor will do this. Okay. All right, so let's close that. Now let's do the opposite side. We're going to make the second side vise visible. Flip around. Highlight the second operation. Position the model and the vise in a way that you can see the origin, your work coordinate system, and see the blank in there. So now we're going to do a setup sheet. Okay, should look something like this. You're double checking all your numbers. This one's 8,000 RPM 2. Our minimum Z shouldn't be any less than 0.495. If it's lower than that, we've got a problem. Here's your tools that you need to put on your traveler sheet. Okay. Work coordinate system 1 on a Haas is G54. Okay, now we're going to post-process this one. Same routine. Download it somewhere where you know where it is. For Haas's second next generation controller, hit post. We're going to open our NC code and we're going to edit this by putting in a note that says use 1.5 inch parallels, tall parallels. And that'll be in the code, and so that we know on the second side we need to use shorter parallels than the first side. Okay, now in Canvas you should be submitting 4 files: an OP1 setup sheet, an OP2 setup sheet, an OP1 NC code, and an OP2 NC code. You also need to have hard copies that are submitted with your project. If that's not all complete, when you submit your project with your part, you will not get full credit. So make sure you do that. All right, that's it for this one, and I'll catch you on the next one.